friends, my name is Amita and in this video I am going to discuss about a very important topic of in power electronics, that is a three-phase inverter 150-degree mode operation. Dear friends, three-phase inverter is a kind of power electronics converter by which we can convert a DC supply into a three-phase AC supply. Dear friends, three-phase inverter can operate in a three modes. One is a 120-degree mode, another is a 180-degree mode, and third one is a 150-degree mode operation. Dear friends, if you want to go for in 120-degree mode and 180-degree mode operation, kindly refer the link which I have given in the description. You can go through that link and can understand how the three-phase inverter operates under 120 and 180-degree mode operation. This video I am mainly focusing on a three-phase inverter operating at a 150-degree mode. Now, one question can be in your mind, what is the meaning of operating mode? When I say that 150-degree mode operation means each SCR connected to the power circuit diagram of a three-phase inverter will conduct only for a duration of 150. Similarly, if I talk about 120 or 180, that means the SCR connected to the power circuit diagram, they will be respectively conducting for a 120 and 180 degree duration. So my dear friends, without wasting time, I am taking you on a screen where I will brief you the three-phase inverter 150-degree mode operation. So now let us start with three-phase inverter. Three-phase inverter, basically it is a power electronics based converter which converts DC supply into a three-phase AC supply. You can write like this: DC supply will be the input, and with the help of inverter we can convert that into a AC supply, and that is of three-phase. Then only it will be called as a three-phase inverter. My dear friends, if you see its power circuit diagram, that will be like this. It is having the 6 number of SCRs, T1, T3, T5, 4, 6, 2. They are the SCRs. So total number of devices that we have used in the power circuit diagram, that is 12, that are 12. Out of that 12, 6 will be the SCR and 6 will be the diode. And these 6 SCRs and 6 diodes are connected in the form of 3 lags. Each lag will have in 2 SCRs and they are connected in a back-to-back position. Like T1, T4 makes one lag, T3, T6 makes another lag, and T5 and T2 makes the third lag. Here you can observe that each SCR is connected one diode which is in parallel to it, and it is connected in an anti-parallel mode. Anti-parallel mode means it is like the anode of a T1 is connected to positive supply, then the cathode of a D1 is connected to positive supply. So what is the use of these diode, anti-parallel diodes? When the SCRs are in reverse bias condition, under that condition these diodes will be forward bias and they will provide a bypass path for the flow of current during reverse biasing of the SCRs. And you can see that the output of this three-phase inverter is connected to a three-phase load, that is ZA, ZB, ZC, and which is connected, and that load is connected in a star fashion. So if it is A phase, this is B phase, and this is C phase. So this is something about the power circuit diagram of an three-phase inverter. Now let us talk about the next topic, that is assumption. As far as the assumptions are concerned, there are 3 assumptions. Each SCR from the same lag will conduct after a duration of 180 degree. That means lag 1 is having T1, T4. That means if the T1 start conducting at 0, T4 can only start conducting at 180. So this is the first assumption, that the SCR from the same lag will start conducting after a duration of 180 degree. Then the second assumption is SCR from the same group, means the positive group or negative group, will conduct after the duration of 120 degree. What is the meaning of a SCR from the same group? Like in this power circuit diagram, you can see that 1, 3, 5, these three are the SCRs whose anode is at similar potential because they are short circuited and connected to the positive supply. That means 1, 3, 5, they are called as a positive group SCR because they can conduct only when the maximum positive supply connected to it. Similarly, 4, 6, 2, their cathodes are common and connected to the negative supply. So they will be conducting only when the maximum negative supply connected to it. That's why they are called negative group SCR. And the third assumption is each SCR will conduct only for the duration of 150 degree, as we are discussing about the 150 degree mode operation. Now, my dear friends, the next thing which we are going to discuss, that is the conduction diagram. So next thing is conduction diagram. Now, to make the conduction diagram, what we are supposed to do, we are supposed to draw the three parallel rows like this, and this is for first leg T1, T4, this is for second leg T3, T6, this is for third leg T5, T2. Now, let's see, this is 0 duration. If T1 start conducting at 0, then as per the assumption 1, the next SCR of the same leg can only start conducting at 180 degree. So this is 360. As per the assumption 2, the SCRs from the same group will start conducting after an interval of 120. So that means the T3 will start conducting at 120. And after 180 degree means at 300, the next SCR T6 can start conducting. Similarly, if I talk about the third leg, T5 can only start conducting at 240, and 240 if I add 180, that means what I am going to get 60. So 60 tak T5 can conduct, and after this the T2 can only start conducting. Now, as per the third assumption, as we are talking about 180 degree mode, 150 degree mode operation, as we are talking about 150 degree mode operation, that each SCR is going to conduct only for the 150 degree duration. So, what we can do, so T1, if it is start conducting at 0, it can conduct only up to 150. So, 150 to 180 will be the duration when no SCR is conducting. If T4 is start conducting at 180, so it can conduct only up to next 150, that is up to 330, and 330 to 360 will be the duration when no SCR is conducting. Similarly, if T3 start conducting at 120, it can only conduct up to 270, that is for next 150 degree duration, and 270 to 300 will be the duration when no SCR is conducting. And similarly, when T6 start conducting at 300, so it can conduct only up to next 150. So next 150 is 60 and 60 plus 90. So that means 90 to 120 will be the duration when no SCR from leg 2 is conducting. At the same time, T5 starts conducting at 240, so it can only conduct up to 150 duration. The 240 if I add 150, that means it can only conduct up to 30. And 30 to 60 will be the duration when no SCR is conducting. Similarly, if T2 start conducting at 60, then for the next 150 matlab 210. So 210 to 240 will be the duration when no SCR from the lag 3 is conducting. Now, based on this, we are supposed to make the conduction table.
So this is the conduction table. We are supposed to write the duration at an interval of 30 up to 360. Then with the help of conduction diagram, we are going to write the conducting SCRs. Now when these SCRs are conducting, how we have written these conducting SCR, that will be clear from this conduction diagram. Like if you see 0 to 30, so 0 to 30, T1 is conducting, T6 is conducting, and T5 is conducting. But when we talk about 30 to 60, only T1 and 6 are conducting, because in the third lag, there is no conducting SCR between 30 to 60. So with the help of this conduction diagram, we will determine the conducting SCRs in the respective duration. Now, let us try to calculate the phase voltages. If you can observe this table carefully, alternatively 3 and 2 SCRs are conducting. Like 0 to 30, T1, T5, T6 are conducting. Whereas if I talk about 30 to 60, it will be T1 and T6. So alternatively 3 and 6 SCRs are conducting. So let us try to determine the voltages, phase voltages. So initially I will write from, so let us start between 0 to 30 duration. 0 to 30 duration, which SCRs are conducting? T1, T5 and T6. So when these SCRs are conducting, if I draw the equivalent circuit of a power circuit diagram, T1 is conducting, so T1 will be short circuit. Then the next SCR, T3 is not conducting, so it will be open circuit. T6 is conducting, so it will be short circuit. This is T1, this is T4 and this is T6, and T5 is also conducting, so T5 will be short circuit, and T2 is not conducting, so it will be like this. Now it is connected to a supply voltage of Vs, and the load is connected, three-phase star connected load. We are supposed to draw like this. This is your ZA, this is your ZB, and this is your star connected load ZC. This is phase A, this is phase B, and this is phase C. Now, if I redraw this circuit, that will be like this. This is a Vs voltage. You can see that ZA through this T1 short circuit is connected to positive voltage. So ZA is connected to positive voltage, and this is A phase. Similarly, ZC through this T5 short circuit is also connected to A phase. So ZC is also connected to A phase. This is C, and they are connected to the neutral point. This is your neutral point, and you can see that the B phase through this T6 short circuit is connected to the negative of the supply. So this will be the equivalent circuit, and this is your B phase. Now, if I want to determine for balanced load, your ZA is equal to ZB is equal to ZC, and that is equal to Z. So the circuit we can make like this. So the above circuit I can draw like this. This is your Vs, and I can draw like this is Z, this is Z, and these two are short circuited, and this is again Z. Now this is B, this is A, and this is C, and this point is neutral. So if I want to determine the VAN, VBN and VCN, that I can determine with the help of voltage division formula. So you can see that these two impedances are in parallel. So what will be the equivalent? That is Z by 2. That will be the equivalent. So if I want to determine VAN, VAN will be Vs, and the equivalent impedance will be Z by 2 upon Z by 2 plus Z. So this is the total equivalent impedance. This is nothing but it is voltage division rule. Okay, so what I am going to get, if I solve it, Vs Z by 2 divide by 3Z by 2. So Z by 2 से Z by 2 cancel. What I am going to get? I am going to get VAN is equal to Vs by 3. And in parallel combination, we know the voltage same. So Vcn is also equal to Vs by 3. Now, if you want to calculate VNB, VNB is equal to Vs into Z upon Z plus Z by 2. So what I am going to get? Vs Z upon 3Z by 2. So what I am going to get? 2 Vs by 3. So VNB is 2 Vs by 3, but my job is to calculate VBN, that is minus VNB. So VBN is equal to minus 2 Vs by 3. So VAN is Vs by 3, VBN is minus 2 Vs by 3. So let us write VAN. What is VAN? VAN is Vs by 3, VBN is minus 2 Vs by 3, and VCN is Vs by 3. So this is how we calculate it for 0 to 30 degree. Now let us try to calculate for 30 to 60. So 30 to 60 ke liye how we are going to calculate? So let us rub this. Now next duration is 30 to 60. So 30 to 60 duration, which SCRs are conducting? T1 and T6. So this will be the diagram. Now 1 will be short circuit and 6 will be short circuit. If I redraw this circuit, that is Vs, and through T1 short circuit, the ZA is connected to positive, and through T6 short circuit, the ZB is connected to negative of the supply, and this is neutral, and C phase is neither connected to positive of supply nor connected to negative supply. Now if it is a balanced load, that means this is also equal to Z and ZB is also equal to Z. So by voltage division formula, if I calculate VAN, then VAN will be equal to total voltage multiplied by Z upon Z plus 2. So what I am going to get? Vs by 2. Similarly, if I calculate VNB, that is Vs upon Z plus Z. So means Vs by 2. So if I calculate VBN, that is minus VNB. That means minus Vs by 2. So VAN is Vs by 2, VBN is minus Vs by 2, and VCN is 0. So what I can write? This will be Vs by 3, this will be minus 2 Vs by 3, and this was Vs by 3. So what we have calculated, that VN is Vs by 2, VBN is minus Vs by 2, and VC is 0. So next duration is 60 to 90. So 60 to 90, 1, 6 and 2 are conducting. So that means this is also short circuit. Now if I redraw this circuit, it will be Vs through T1 short circuit, the ZA is connected to positive of supply, and through T6 and T2 short circuit, the ZB and ZC are connected to negative of the supply. This is B, this is C, and this point is neutral. Now for a balanced load, as we know, ZA is equal to ZB is equal to ZC is equal to Z. So this is equal to Z, this is equal to Z, and this is equal to Z. So V and B, that is also equal to V and C. That will be equal to Vs, and if I solve it, I will get Vs by 3. And VBN is equal to VCN, that is minus Vs by 3. Similarly, if I am going to calculate VAN, that is Vs upon Z by 2. So what I am going to get? 2 Vs by 3. So VAN is 2 Vs by 3 and VBN VCN is minus Vs by 3. So let us write this thing into table. So what I am going to get? VAN is 2 Vs by 3, and VBN and CN, that is minus Vs by 3 and minus Vs by 3. So this is how we will get it for 60 to 90. Now 90 to 120, if you see 90 to 120, which SCRs are conducting? 1 and 2. So if I draw it for 90 to 120, 1 and 2 are conducting. So 1 and 2 are conducting means ZA is connected to positive and ZC is connected to negative. So ZA positive means ZA is connected to positive and ZC is connected to negative. So what I am going to get, ZA is connected to positive means I am going to get Vs by 2, and ZC is connected to negative means I am going to get minus Vs by 2. Similarly, here I am getting T1, T2, T3, 120 to 150, 1, 2, 3. So if 1, 2, 3 SCRs are conducting, so let us see the power circuit diagram. 1, 2 and 3. 1, 2 and 3. If 1, 3 and 2 are conducting means 1 or 3 short circuits, say A and B connected to positive and C is connected to negative. So A and B are connected to positive. What it means? A and B are connected to positive. That means what we are going to get? Vs by 3, Vs by 3. So A and B are connected to positive means I am going to get here Vs by 3, here Vs by 3, and here I am going to get minus 2 Vs by 3. Similarly, T2 to T3, when T2 and T3 are conducting, that means here I am going to get 0 and here I am going to get Vs by 2 and here I am going to get minus Vs by 2. When 2, 3, 4 are conducting means minus Vs by 3 and then Ps by 3, and here I am going to get minus Vs by 3. Here when 3, 4 are conducting, when 3, 4 are conducting means what I am going to get? 0 and not 0, 2, 3 are conducting, minus Vs by 3. So here I am going to get minus Vs by 2 and here I am going to get Vs by 2 and here it is 0. 3, 4, 5. So 3, 4, 5 mein I am going to get minus 2 Vs by 3 and here I am going to get Vs by 3 and here I am going to get Vs by 3. Now again 4, 5, when 4, 5 is conducting, minus Vs by 2, here Vs by 3, Vs by 2, here I am going to get again 0 and here Vs by 2. Here I am going to get minus Vs by 3, here Vs by 3 के बाद minus Vs by 3 and here Vs by 3, Vs by 2, then 2 Vs by 3. And 5, 6 are conducting means here I am going to get Vs by 3, 0. This I am going to get minus Vs by 2 and this I am going to get Vs by 2. So this is how we will get the phase voltages. Now if I calculate the line voltage, VAB means it is VAN minus VBN. So if I subtract VBN from this, what I am going to get? Vs by 3 minus of, so means Vs. What I am going to get here? Vs. What I am going to get here? 2 Vs by 3 minus of minus Vs by 3, matlab Vs. What I am going to get here? Vs by 2. This is 0. This is Vs by 2. Here is minus Vs. This one is minus Vs. This one is minus Vs. This is minus Vs by 2. and this is minus, this is 0, and at last I am going to get Vs by 2. So this is VAB. Now similarly, if I want to calculate VBC, so what VBC I am going to get? VBC will be like this minus, so VBC will be VBN minus VCN. So if I subtract this Vs by 3 from A, so I will get minus Vs. So this will be minus Vs by 2. This will be 0. This will be Vs by 2. This will be Vs. This will be Vs. This will be Vs. This will be Vs by 2. This will be 0. This will be minus Vs by 2. And this will be minus Vs. And this will be minus. Now let us write VCA, this minus this. So what I am going to get? 0. This minus this, so means minus Vs by 2. Then this minus this means minus Vs. Then this minus this, again minus this minus this. Minus 2 Vs by 3, so again minus Vs. This minus this means minus Vs by 2. And this minus this, so what I am going to get? 0. And again Vs by 2. And this minus this, so Vs. So this minus this is minus Vs. Not minus Vs, plus Vs. And this minus this means Vs. And this minus this is Vs by. Now this will be the conduction table. Now if you plot the waveform, you can see that A phase voltage is Vs by 3, Vs by 2, 2 Vs by 3, like this. Vs by 3, Vs by 2, 2 Vs by 3, Vs by 2. So like this we are supposed to plot. Now let us plot the y-axis. Here we are having VAN, VBN and VCN. This is VAN, this is VBN, this is VCN. Now VAN I am going to plot by green color, VBN I am going to plot by white color, and VCN I am going to plot by yellow color so that we can differentiate. Now let us mark the instance. This is 0, this is 30, then 60, then 90, then 120, then 150, 180, 210, 240, 270, 300, 330, and at last 360. Now if I extend these instants like this, so let me choose green color. This will be green color. Now we know the value is here Vs by 3, then Vs by 2, then 2 Vs by 3, then Vs by 2. That values I am plotting from the conduction table. Then 0, then minus Vs by 3, then minus Vs by 2, then minus 2 Vs by 3, then again minus Vs by 2, then minus Vs by 3 and 0. So this is how we are going to get the VAN. Now if I plot VBN, that I am plotting by white color, this is Vs by 3, then Vs by 2, then 2 Vs by 3, then Vs by 2, then Vs by 3, 0, minus Vs by 3, minus Vs by 2,
minus 2Vs by 3, then minus Vs by 2, then minus Vs by 3 and 0. So this is what we are going to get the VBN. Now similarly, if I plot VCN, that I will plot by yellow color. So if I plot VCN, here I am going to get Vs by 3, here Vs by 2, here 2Vs by 3, then Vs by 2, then Vs by 3, then 0, then minus Vs by 3, then minus Vs by 2, then minus 2Vs by 3, then minus Vs by 2, then minus Vs by 3 and 0. So if you see all these three waveforms, the value of VAN is having the value of Vs by 3 at 0, whereas the same cycle repeats for VBN after 120, and for VCN it repeats at 240. So 120 and this is 240. That means if you observe this cycle, it repeats its value after an interval of 180, 120. So VAN, VBN and VCN, they are apart by an angle of 120. And this is nothing but three-phase AC supply. So that means with the help of three-phase inverter, we are going to get the three phases AC voltages. Now the next thing is we are going to draw the line voltages. So line voltages waveforms, and they are nothing but VAB, VBC and VCA. So what I am going to do, let us extend the y-axis here. So first is VAB, second one is VBC and third one is VCA. Let us draw the instants 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330 and 360. Extend the waveforms, extend the instants. As you know that the line voltages are the differences of the phase voltages, like VAB. VAB is nothing but it is VAN minus VBN, means it is the difference of a phase voltage of A to the difference of a phase voltage of B. So draw the line voltages waveform. So it will be, let me write here, I am plotting VAB by green color, VBC by white and VCA by yellow color. So let us choose the green color. So this is 0 to 90. For all three duration we are getting Vs voltage. Then 90 to 120 we are getting Vs by 2. Then 120 to 150, 0. 150 to 180, that is minus Vs by 2. Then again for 3 duration it will be minus Vs. Then minus Vs by 2. Then 0. And then Vs by 2. So this is how we are going to get the line voltages of AB. Now if I plot the line voltage for VBC, so VBC means for 3 duration I am going to get Vs, then Vs by 2, then 0, then minus Vs by 2 and then 3 times we are going to get minus Vs, then minus Vs by 2, then 0 and then Vs by 2. So this is how we are going to get VBC. Now at last, if I plot VCA, so VCA from this point to this point I am going to get Vs, then Vs by 2, then 0, then minus Vs by 2, then 3 times I am going to get minus Vs, then minus Vs by 2, then 0, and then here it will be Vs by 2. So if you closely observe these waveforms, VAB value is having Vs at 0, and the same value of Vs, VBC is having at 120, and VCA is having at 240. So what it concludes that VAB, VBC, VCA, they are displaced by an angle of 120, and that is 3-phase AC supply. Now if you observe these waveforms, how many labels I am getting? I am getting minus Vs label, minus Vs by 2, 0, Vs by 2, Vs. So that means the total number of labels in the line voltages are 5. Whereas the labels in the phase voltages, one of the phase voltage I am having here, 1, 1, 0, minus Vs by 3, minus Vs by 2, minus 2 Vs by 3. So 1, 2, 3, 4, 5, 6, 7. So that means the phase voltages are having the 7 label, and 7 label waveforms we are getting, whereas for the line voltages we are getting the 5 label output. My dear friends, whatever information I have shared in this video related to a 3-phase inverter 150-degree mode operation, that you are able to understand well. Dear friends, if you like this video, kindly press the like button, and if you are interested to learn its another 2 operating modes, that is 120 and 180-degree mode, then please follow the links that I have mentioned in the description. There you can understand the 120 and 180-degree mode operation. My dear friends, if you like this video, kindly press the like button, and if you feel that whenever I make such kind of videos related to power electronics, the notification should reach to you, then don't forget to subscribe my channel. Thank you.